Okay, so let's start off by talking about some of the basic problems that Redux was created to solve. Now at first glance, the problems that Redux solves are going to look an awful lot like the problems that are solved by context in React. So let's just describe that real quick. Let's say, for example, that in our application, we have a pretty deep hierarchy of components, right? So we have a page component, maybe we have some kind of section component over here. This section component might have its own subcomponents, and each of these might have their subcomponents as well. Okay, so we have a pretty hierarchical layout to our app, as most Reacts tend to turn into over time. And let's say that over here we have a separate section component, which is a direct child of our page component here. And this one has its subcomponents as well, and each of those subcomponents has its own subcomponents. Now, when we have a basic layout like this, there are several different ways to handle state in our application. One way is to have each of our components control its own state. Okay, so our components down here would each have their own state that they basically handle themselves. None of the other components above them cares about it. Now, this solution is only sustainable insofar as our components don't need to share state. Okay, so let's say, for example, that this component here, which we'll call component 1, has to share state with this component here, component 2. Well, that's not too big of a deal because all we have to do in that case is move the state for these two components up into here, right, up into the parent component that they have in common, and simply pass that state down to each of these components as props. Okay, so not too big of a deal there. How about if we want this component here, which we'll call again component 1, to share state with this component, which we'll call component 2. Right? Well, in that case, it's a little more complicated. We have to not only lift the state up to here, we have to lift it all the way up to here, which is the only parent component that these two components have in common, right? Assuming that the hierarchy goes like this, of course. Okay? So in that case, what we would have to do is we would have to put the state for these two components, right, whatever state they needed to share, all the way up inside this component. And then what we would have to do is pass that state down as props not only to these two components here, but to their parent component. So all of a sudden, this parent component here has to start caring about props that it doesn't even need to use. And all it does really is passes it straight down to its child components. The same thing would be the case for this other subtree here. We would have to pass it down to this parent component, which doesn't actually use that prop, and that parent component would have to pass it down to our component 1 here. So you probably see where this is going by now. What if our component 1 here had to share state with one of the components over here? All right, we'll call this component 2 now. Well, what we would have to do in that case, the state would have to be all the way up inside of here, and we would have to then pass that as props all the way down to wherever it needed to go, right? So to component 2, we would have to do the same thing for component 1, pass it all the way down to there through these intermediary components, which don't even use it. They literally just pass it down to the next component without really even knowing what it does. And the same thing is true, right? Let's say that we want our component 1 and component 2 now to be able to modify this state. In addition to passing down the state, we would also have to pass down some kind of function that this component could call in order to change the state. So we would have two props basically being passed down through most of our component tree just because our little component 1 here and our little component 2 over here want to share state. Now, if this sounds painful, it is, and this usually leads to something called props drilling, which we've discussed a little bit earlier. And basically props drilling, or waterfall props as some people call them, is this can basically take perfectly good reusable components like our innocent component up here and turn them into components that are very hard to reuse because they require all these props that they don't even use. Now, we saw earlier that one way to mitigate this situation is simply to use context in React, right? We saw that what context allows you to do, if you have context up here and a page component that's sort of wrapped in that context, and subcomponents of this page component, which we'll draw out like this. Okay, we saw that what context allows these components to do is actually get direct access to that context state. All right, so if our components 1 and 2 wanted to share state now, all they would have to do is connect to this context, and they would be able to avoid adding unnecessary props to their parent components in the process. Now, one of the problems that people tend to run into with context is complexity, right? In the friend tracker application that we've been building in other videos, the context that we've had so far is, pretty simple. It doesn't really require too much specific knowledge to see what's going on with any of the individual functions. But as your applications get more and more complicated, context can quickly get out of hand to the point where it just becomes a little bit unmanageable, right? You have essentially what you end up with most of the time with context is one central context of your application for a given resource, and you end up usually with about 10 or 20 or 30 different components all using that context at the same time, all making changes to that context, and more often than not, what ends up happening is your application ends up re-rendering unnecessarily. The components start to make changes to the context that they shouldn't be making, right? People just feel free to add whatever functions they want to the context in order to manipulate the state. That's generally where context ends up in larger applications, unless you have a very disciplined team of developers, which usually is not the case, I will say. So here's where Redux comes in and what I find that it's particularly good for. Redux works off the same basic concepts as context does, okay? And as you'll see, it actually does use context behind the scenes, but what it does is it adds a sort of layer of rules, if you will, between the context and the components that want to use it. So while for context, you can basically add whatever functions you want and manipulate the state in whatever way you want, these rules around the context make it so that components can only make specific predetermined changes in very specific ways. We're going to see what this looks like very shortly. But essentially, now the components here are restricted to only interacting with the context in ways that we've defined through the rules. Okay, so they kind of have to play by Redux's rules. So that's the main purpose of Redux there. And this kind of feeds into something that I hear quite a bit, a question that I get a lot about Redux, and that is, do we really need Redux if we have context? And the answer to that is yes, right? At first, when you're building smaller applications, it might not seem like it, but as your applications get larger and larger, having this layer of rules between your components and the context of your application can be a real lifesaver. Well, I hope this has been informative for you, and I'd like to thank you for viewing.